So in this video, I want to go back to the random variable we were working with in workshop 7A. So what was that? We started off with just a picture of the PDF, and the PDF 0, and then it was a line going up like this, and then it was 0 again. There's a line up to the point where x equals 1. And one of the first things you had to do in the workshop was to find what this value over here, the height uh, on the x-axis would be. And you found the height needed to make the whole area equals 1. We found that it was 2 here. And that allowed us to write down the information in this picture in the form of an equation. And we did that. The PDF equation is that f of x is 2 times x. Okay, so it's this line has a slope of 2. And that is for the range x between 0 and 1 and 0 everywhere else. And I believe we also found the CDF here by integrating. This is all review of workshop 7A. You can go back and go through the answers again if you want to refresh that. That was a workshop that was hard at the time. I'm hoping you'll go back and maybe see that it's not so hard after you get a little more practice. But just recapping what we found there, we found that the CDF for this example was 0 when b is less than 0. Of course, when b's over here, probability that x is less than that is 0. It was 1 for b greater than 1. Again, that's obvious. Once we get over here, for picking a value like 2, the probability that x is less than 2 is 1 because all the probability is here between 0 and 1. And that the kind of interesting part of the PDF in this range here, what we had is the CDF, remember being the integral of the PDF, that it was b squared for b between 0 and 1. Okay, so that's just all review. Now that we have the CDF, we're going to use the same random variable in this lesson, which is going to be about conditional probability. But let's just first remind ourselves that we can plug any number we want in for b and get the probability that x is less than b. So if we want, for example, the probability that x is less than 1/4, we just plug in 1/4 for b there, and we get 1/16. Okay, so once we have the CDF, it's just plugging in any number we want to get a cumulative probability. Fine, that's all review. Let's now go on to the topic I want to focus on here, which is what about conditional probability? Okay, I'm going to say something predictable about conditional probability. You guys can probably predict. I'm going to say it's just like the other cases. Conditional probability works the way it always does. And that is true. But once we have continuous random variables, things look a little bit different, even if the logic is the same. So I want to go through in this video and the next one what conditional probability logic looks like in using the symbols that we use for continuous random variables. Okay, so what if we are looking for this? What if we want the probability that x is less than 1/4 conditional on the probability that x is less than or equal to 2/3? Okay, so we start off, we've got this PDF, and somebody tells us, you know what, we know that x is not in this top range here. We know that x is below 2/3, can we update our probability about the likelihood that it would be less than 1/4 given this new information? A good thing to do when you are thinking about this contrasting unconditional probability with a conditional probability is it's a good time to touch base with your intuition. If we learn that X is less than 2/3, the probability that X is less than 1/4 should be larger than it was before we knew that X is in the lower range here. Okay, so let's use math to figure that out. And all we're going to use is the definition of conditional probability is the same definition of conditional probability that we have been working with this whole class. Okay, so let's just write it in here. It is the probability of the joint event divided by the probability of the conditioning event. It is the probability that X is less than or equal to 1/4 and X is less than or equal to 2/3 divided by the probability that X is less than or equal to 2/3. Same as it's always been. Joint probability divided by the probability of the conditioning event. It's just emphasizing this is the definition of conditional probability. Same thing all along. That's all we're going to do. And we're going to use the CDF to figure out the numerator and the denominator here. Really very, very straightforward. Okay, so for the numerator, we have probability, just writing it again, that X is less than 1/4 and X is less than 2/3. Okay, so just thinking about this, sometimes you can just see it, thinking about it. The probability that X is both less than 1/4 and less than 2/3 is the probability that X is less than 1/4. Okay. This event, X is less than 1/4, is a subset of the event, X is less than 2/3. So the intersection is just the smaller set here. If that doesn't seem quite clear in thinking about it, let's just look here and say, I'm not really drawing this to scale, but let's say that's 2/3 there. So this green, that's the conditioning event here. And what is the probability we're interested in here? 1/4. What is the intersection? It is 1/4 here. The probability X equals 1/4. Okay. So that numerator is the probability that X is less than or equal to 1/4. And we already found that. We found that in a little example up here. That is 1/16. Okay, so that's what we have in our numerator. And for the denominator, probability that X is less than or equal to 2/3. Okay, we're just going to use the CDF. We're just going to plug in 2/3 right into that CDF. It is this CDF with B equals 2/3 here, and that is 2/3 squared. That is 4/9. Okay, so going back to what we're looking for here, the probability that X is less than or equal to 1/4, conditional on the probability that X is less than or equal to 2/3 is 1/16 divided by 4/9. That is 9/16. It's 9/64. It's 9/16 times 4 is 64, and that is indeed consistent with our intuition. That is a bigger number than the unconditional probability. Let's see. Okay, so zooming out here for the big picture, finding conditional probabilities with continuous random variables is no different than finding them for discrete random variables. We look at the joint probability divided by the probability of the conditioning event. The way we find those probabilities is different because that's different with continuous random variables, but the big picture logic is the same. Zooming in, all we did to find these probabilities was plug numbers into the PDF. The only place where things got a little bit tricky was just to figure out what this joint probability is here. Okay, and so in this case, the event in questions is actually the joint event here, that the x less than or equal to 1/4 is a subset of s less than or equal to 2/3. So the probability that x is both less than 1/4 and less than 2/3 is just this probability. So that was really the only tricky part of this problem. And that is kind of like, again, we're going really back to the basics of this course, thinking about sets and intersections. And I used a little picture here. It wouldn't have been wrong to draw a Venn diagram as well, but that's how we got our conditional probability.